Hey guys, and welcome back to one of these videos where we go through aiming for grade 9 papers. So just so you're aware, I've done a bunch of these papers before. I'm going to leave them all linked in the description. So there are 3 sets with 3 papers in each so far. So that's 9 papers in total. We have 2 left. We have this paper 3 and we have the set 3 paper 3 as well. So I'm going to leave the rest of them in the description. You should definitely check those out with the links to the actual papers themselves. So as we go through these questions, I just want to bring a few things to mind. So one is, are these all grade 9 questions? They are essentially the hardest question you can get for each topic, because not every topic is grade 9. So hopefully that makes a bit of sense. So as I go through these questions, I want you to I'm going to explain my thought process. So if I were in this exam, I've approached this question, how do I know what to do? What words tell me what to do? That kind of thing, because that is how you get to a grade 9, is really understanding what you're doing. So that's exactly how I'm going to explain it. So again, as we go through these, you can have a go first and then come to this and use it as like a mark scheme, or if you want, you can watch me do it, understand my thought process, and then in a day or two, have a go yourself. I would prefer the latter one personally, but without further ado, let's get straight into it. So the first question here, we have a prism. It is a 5-mark question, and it's made up of a triangle and a rectangle as the kind of cross-sectional area, and then it's 20 centimeters long. So if we read through it, it has one line of symmetry. Work out the volume of the prism. Now, how do you work out the volume of any prism? Now, whenever I ask people this, they try and remember a formula. So for example, the volume of a cylinder, they'll try and memorize a formula. The volume of a rectangular prism, they'll memorize a formula, things like that. That's not really the best way to do it. All you need to know is a prism is a 2D object, 2D shape, that's been stretched back. So the volume is just the area of the front face times by whatever the length is. So if you have a cylinder, that front face is a circle. What's the area of a circle? It's pi r squared, and then the length would just be whatever the length is. If it's a rectangle, it's the area of a rectangle times by however long it is. So in this case, we have a different style of prism. The reason why that's really important for kind of the grade 9 version of this is that this is a shape that is a compound shape. It's unusual. You wouldn't have come across an equation that tells you how to work out the volume of a house-based prism, whatever you'd want to call that. Instead, they expect you to know that it's going to be the area of this front shape, this whole thing here, this rectangle and triangle added together, then you times it by 20. So that seems like not that much for 5 marks, but if you have a look, well, first of all, we want the area of the front face. So the area of the front face is actually made up of 2 areas. It is the area of a rectangle plus the area of a triangle. Now, there is a reason why I write out my work like this, because when your examiner is marking, they need to be able to see a logical series of steps. So it's good to write the stuff out. Now, the area of the rectangle, that's quite easy. That's just going to be 10 times 12. But the area of the triangle is going to be base times height divided by 2. And the problem is I don't have a base and I don't have a height. So that's where things are going to get a bit trickier. So we need to use all of the information in this diagram. So I've used the 12 and the 10, and I know I'm going to use the 20 to work out the volume, but I haven't used this 40 degrees. The next thing I haven't used is the one line of symmetry. The line of symmetry is straight down the front. So in other words, this triangle here is actually an isosceles triangle, because these 2 sides must be the same length, and therefore this is also 40 degrees as well, because there is a line of symmetry. So how does that help me? Well, if I just extract this triangle for a second, so if I extract that out here, like so, we have a 40 degrees here. In order to work out the area of a triangle, you need the base, which I have. The base is 10, right? So I have that base is 10 centimeters, but I actually need the vertical height, the perpendicular height. So what I'm going to do is I'm actually going to get rid of that 10 just for now. And because this is symmetrical, that straight line down cuts the base in half, meaning this here is 5 centimeters. So I actually have a right angled triangle now. 40 degrees, where that is 5 centimeters, and I want to work out the side h. So I'm going to be using trigonometry. In terms of trigonometry, well, we have the opposite side and the adjacent side, so we're going to be using tan. So we have tan 40. Let's write it over here. Tan 40 equals opposite, so h, over adjacent 5, which means h is just equal to 5 tan 40. And then all we can do is just use our calculator, because remember paper 3s are always calculator exams, to type that in. So 5 tan 40, which gives us an answer of 4.195. I'm going to call that 4.20. It does say 3 SF for all of our answers. So now our area of the triangle is base times height. So the base is still 10, don't forget, because we are talking about the overall big triangle here. And that base is 10, and the height was 4.2. So 10 times 4.2 over 2. And that is going to be the area of the front face. So 10 times 12 is 120, plus 42 over 2 is 21. So that is going to be 141 centimeters. And then for the volume, all we need to do is times the area, which is 141, and multiply it by 20, which should give us 2,820 centimeters cubed. Let's just make sure I'm correct on that. So times by 20, 2,820 centimeters cubed. Don't forget the centimeters cubed. And that's 5 marks. So if you look, the actual length of the question isn't that bad, but it does include quite a few different things. And that's what you need to expect from grade 9 questions. Is A, it's an unfamiliar shape. B, they've included things like trigonometry in here as well. And C, the actual overall steps might not be that many or that complicated, but knowing what to do is the real key thing here. Here we have everyone's favourite ratios question. But again, I want to hopefully explain this. Now, with ratios, they're not too difficult if you really understand them. So I'd advise, if you're really unsure, go back to the basics and really understand what the hell a ratio is and what it shows. It shows proportion. Okay, so for example, this 9:1 here means that Olivia has 9 times as many as Jessica, as an example. So Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. Fran and Gary share their sweets in the ratio of 2:3. Olivia and Jessica share their sweets in the ratio of 9:1. Then it gives you this, like W, X, Y, blah, blah, blah. Basically, they're asking you to combine this ratio. That's it. Okay? However, they have this additional criteria here that in total, Jessica should have half as many as Fran and Gary. So that is another thing we have to take into consideration. But at its core, they're just saying, hey, combine this ratio, but then make sure that Fran and Gary have twice as many as Olivia and Jessica. And this is a 4-mark question. Now, there are so many ways to do this, and I'm going to kind of show you my way, which I personally think is obviously much easier. So in general, as you can see, if we have Fran and Gary, so one way is we can actually lay this information out just one more time like this, so 2:3. When you're combining your ratios, you would normally try and look for a letter that's in common and make that number the same. However, as you can see here, there are no letters in common, so what do? You make the number of parts the same. So if I add up the number of parts in both of these, Olivia to Jessica, 9:1, in total, that is 10 parts. Right, because 9 plus 1. And here for Fran and Gary, we have 5 parts. So all we want to do is make the number of parts the same. So what do? Well, I can times this one by 2. I don't want to divide this one by 2 because then I get fractions. That's a bit messy. So this one I'm going to times by 2 instead. So if I times both sides by 2, we now get 4 to 6. And that does give me the 10 parts. Great. Now normally, I could now just write F to G to O to J is 4 to 6 to 9:1. And that would be my answer. Okay? Normally. The problem is we have this. Olivia and Jessica have half as many sweets as Fran and Gary. Okay? So normally this would be fine. We can just write it as one big ratio. But now we have to do something else. It says Olivia and Jessica have half as many. So that means their actual number of parts should be half as many as Fran and Gary. Okay? So let's say these guys have 10 sweets. Fran and Gary, that should be half as many as however many Fran and Gary have. So what's the best way to do this? Well, I like to reverse it. Half as many as Fran and Gary means that Fran and Gary have twice as many as Olivia and Jessica. So all you need to do is times it by 2 again. Because they should have 20 parts if Olivia and Jessica have 10 parts. Now, why is the multiplying way better? Well, if I divide this by 2, you can see I'm going to get 2 decimals. And in order to find a ratio in its simplest form, you cannot have decimals. So what I'd have to then do is times it to get rid of the decimals when I could have just done that from the very beginning. So, in short, our W to X to Y to Z, which by the way is literally just F to G to O to J, it's just written in a weird way, is you just write the letters. So 8 should be under F, 12 should be under G, 9 should be under O, and 1 should be under Jessica, or under J. That's it for 4 marks. Pretty good. So when I initially saw this question, I probably would have just done this and wrote the answer and would have been done in about 60 seconds. Again, if you understand ratios, and there's only 3 types of questions they can really give you. They have sharing questions, so sharing things in a ratio. They have combining ratios, and inside combining ratios there's 2 types. Either there is a common letter or is not a common letter. And from there's 2 different methods. Once you know those 3 things about ratios, you can do pretty much any ratio question, as long as you have the confidence to apply what you know. So with this question, we have some circle theorems, and of course it's circle theorems because they have a weird shape and a circle inside it, which is always circle theorems. And we have points B, D, E, and F lie on the circle. ABC is the tangent. Find the size of angle ABD. So I like to label whatever angle they're asking me to find in circle theorem questions, which is this one over here. And I think circle theorems is one of those ones where understanding plays a less important role. Now, I know if you've watched quite a few of my videos, you'll probably see that I'm a big proponent of understanding maths, but with circle theorems, there's a lot of pattern recognition. So when I look at this straight away, and I'm looking at this angle here, the first thing that comes to mind is the alternate segment theorem, which I'm not talking about the one that's like the Z angle or anything. I'm talking about the circle theorem that is the alternate segment theorem, which essentially states, if you look here, this line BD creates a segment, this little slice over here, right? And we're looking for the angle inside it. That is going to be the same as this angle over here. Okay, that's what the alternate segment theorem states, in the same way that this angle and this angle will also be the same because of the same reason. And it is just all about pattern recognition. Doing enough of these questions will eventually kind of unlock it in your brain. Okay, this is because you don't really need to know the actual mathematical proof behind it, and it's quite involved. It's quite a hefty proof. So that's what I like to do, is when I look at circle theorem questions, I like to look and say, okay, what am I seeing? What am I going to be using? I can see the tangent, so the one that comes to mind is radius meets tangent at 90 degrees. But if you notice, we don't have the center of the circle, so not that one. The other one I see is, well, we have these 4 points on the circle. So I'm thinking cyclic quadrilateral as well. And then, of course, we have it split up into 2 triangles, so we're probably going to use something to do with angles in a triangle add up to 180. The reason why I haven't said about the isosceles triangle is because, again, we don't have any radii here. There's no radius that is marked here, and if we marked it ourselves, it wouldn't really help us at all. So working backwards, we're going to be trying to find out this angle. So how can we find that angle? Well, this is a triangle. If I knew what this angle was here, I could then do 180 minus this and this to get that angle. Okay, how can I work out that one? Well, this overall shape is a cyclic quadrilateral. And what's important about a cyclic quadrilateral? The opposite angles add up to 180, which means this angle over here, angle DBF, is 180 minus 100, which is 80 degrees, which means the angle BFD is 180 minus 40 minus 80. Or if you want, you can add 80 and 40 to get 120, then do 180 minus 120, it'll give you the exact same thing, 60 degrees. And then all you'd have to do is say, because of alternate segment theorem, it means that ABD is also 60 degrees. So what kind of reasons would we write? Well, the first one I would write is that angle DBF equals 80 because opposite angles in a cyclic quadrilateral. And then I would just say angles in a triangle abs 180, and then alternate segment theorem for our reasons. And that will be more than enough to get us the full 4 marks. They're only looking for 2 correct reasons. Okay, so as long as you have 2 of them, you're completely fine. This is a really, really important question because, and this is what I like about these aiming for grade 9 papers, is they really target areas where students make mistakes. So this is a topic that comes up regularly, but a lot of students kind of neglect it. And the way they neglect it is quite interesting. So all we need to do here is we need to shade the region that satisfies all of these inequalities. So what we need to do is essentially draw the lines representing all of these equations and then shade in whatever region works out. But this is really important. If you have greater than or less than, it has to be a dashed line. It's not a solid line. That's the common mistake I see. In this case, we have greater than equal to and less than equal to, so it is a solid line. But just bear in mind that there have been plenty of questions where they have no equals to, and therefore you're meant to use a dashed line, and pretty much no one's done it, which again is why they've shoved it into this paper. So what do I do? Well, what I do is I change this all into just equal signs for now, okay? And I draw those lines. Now this one here, there's a few things you could do. You could rearrange it in order to get y, which is how I teach it. However, once you get quite good at this, you actually realize you don't need to rearrange it. But I'm going to just to make my point, minus 2x plus 6. So that means y is greater than equal to minus 2 over 3x plus 2. So I'm going to be plotting minus 2 over 3x plus 2, which is not that tricky. And of course we're going to be using our rulers. So x equals 0, that's nice. That's just going to be a flat line along here. So I'm going to write and label it x equals 0. X equals 2, well all you do is you find x equals 2. And actually, no, I should probably label this on the other axis over here, because technically it's going straight up, but it doesn't really make a difference, I'm not drawing anything. X equals 2 is going to be a straight line, and again, it's going to be a solid line because it's an equals to. And sometimes, by the way, half of them will be equals to and half of them will not have the underline. So you have to really be careful with that. And that's going to be a line that's straight vertical. I know it's not straight vertical yet, but watch. There we go. And I would label that again. It's good to label it just so the examiner can see that you've written them all, like especially for this one here. Technically, I haven't drawn anything, but it's good for me to label it so the examiner can see, okay, he has taken it into consideration. X plus 3, that's quite easy. It's going to cross at plus 3, and then because the gradient is 1, every 1 step to the right goes 1 step up. Yeah? And now I've got a few of the points, I can actually draw a straight line going through all of them. I'm going to fix the line, don't worry. It's just not bad. It's not perfect, but hopefully you can see that you'd have to end up over here. Okay, so it's not perfect, but that's okay for the purposes of this. And that's going to be my x plus 3 line. And then we have minus 2 over 3x plus 2. So it starts at x plus 2 here. And then every 1 to the right, it goes down by 2/3. So it's quite a shallow line. So what I would probably do is sub in, because you only need 2 points to make a straight line. So what I would like to do is think of a number that will make it a whole number. If I sub in x is 3, I'll get minus 2 over 3 times 3, which is minus 2, plus 2, which is 0. So x is 3, y is 0. And that way, I can make it quite nice. And do I want to, okay, let me use the ruler this time, just to make it a bit more clear. This ruler, again, isn't perfect, but hopefully you'll get the point, the kind of gist of the question. I think I need to make it a bit more steep. That's not bad. And there you go. We've got a couple of the marks already for drawing those points. So this is a 4-mark question. For writing all of these out, you get 3 marks. The final mark is for actually marking the region. Now here's the next problems. So the first problem is this thing here, which is where we would probably get 2 if we did it as dashed lines instead. Or the other way around. So if this was incorrect, we would get only 2 out of 3, 2 instead of 3 in this case. The next thing is that a lot of students will just go, it's the region in the middle. Cool. Not always. So sometimes they actually make it could be this region over here, or it could be the region outside. You can't guess. It's similar to quadratic inequalities. You know how when we did quadratic inequalities, we had to find out if the inequalities were inside versus outside, right? Same thing here. Most of the time, it's going to be the shape. I'm not going to lie to you. But not always. So, if you have a look, x is bigger than 0, bigger than equal to, so it's going to be to the right of 0, which means it doesn't actually include this little bit here. Okay. So it looks like it's going to be everywhere to the right of the y-axis. It's also less than 2. So it's between these two lines here. Okay. Less than x plus 3, so it's below this diagonal line here. And it's bigger than the bottom line. So it is, in this case, and this is why they ask you to shade it or label it. I would personally shade it just to make sure everyone can see what I'm talking about. It's this region here. And it says label it R. So put a big R there. And that's it for the 4th mark. But it's very clear that you need to make sure that you don't think it's that one there. Okay? If you just put an R here, they should be fine. But just keep that in the back of your mind. Part B is a very interesting question as well. And again, this is where they kind of make things a bit more interesting because they've given you the inequalities and the region itself. And they're just giving you kind of is Jeffrey correct in this case? So he says that the coordinate 2, 4 does not satisfy the inequalities because it does not lie in the shaded region. Is he correct? The common mistake here is to go, 2, 4 is up here. So he's correct. I mean, technically speaking, it is inside the region. Because remember, it's equal to. So if it's along the line, it is still equal to all of these. So one way I would put this is I would say, no, the coordinate is on the line. On the line. Since the inequalities are equal to, well, this satisfies them. Okay? So being along any one of these lines, so any coordinate along this black line or this black line, as long as it's here, is actually still fine. So that's one thing. Now, I'm going to be open with you. I checked the mark scheme before I did this question because there is, and this happens in a lot of mark schemes as well, is where the intended solution is a bit more involved. What they expect you to do, and by the way, this gives you the mark, so you might not always see this on a mark scheme, but this is completely correct, is to sub in x equals 2 and y equals 4 into all of these to see if it's correct. So for example, in the first one, we have y is less than 4x, less than equal to 4x. If I sub in y is 4, x is 4 times 2, well, that gives me 4 is less than equal to 8, which is correct. And then do the same thing with all of these. That's what they expect you to do because that will show that all of the inequalities are indeed satisfied. But I like this because it's a bit quicker, but just so you know, you can do the same thing. So for example, if I look at the second one now, we have 4 is bigger than or equal to a half of 2. Well, 4 is indeed bigger than or equal to 1, so that's also correct. And then lastly, we have 2 plus 4 is less than or equal to 6. Well, 6 is less than or equal to 6, so that also works. So you can do it that way as well. Now, if it says show that it lies in the shaded region, I would do this. But I just wanted to make you aware that that is another answer that they can give you on the mark scheme. This is another topic that, while not particularly difficult once you know the method, it's not answered the best, and that's why it's in this paper as well. Now, I actually want to go through because, again, as I've said before, when you want to look for a grade 9, you really need to focus on the understanding of why you're doing what you're doing. So a lot of you may say, oh, well, 10x equals, and then blah, 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 and happy days, right? Well, sometimes it's not always going to be 10x and 100x or 1000x. They could technically give you pretty much anything. They could make you do 1000x, 10,000x, 100,000x. It doesn't make a difference because the actual reasoning behind it is the same. So why the hell do we do the 10x and the 100x and all this other stuff? Well, to show you that, I am going to do a different method, slightly, just to make it a bit more clear. So, it says prove algebraically, so we need to do algebra. Shockingly, I know. And the only step that I want you to remember is that you're going to write x equals, and you're going to write the number. Okay? Cool. Now, when I write this number, I'm actually going to change it slightly by writing this recurring decimal a little bit. Obviously, I can't write the whole thing out because that's the whole point of it being recurring. But I'm going to get rid of this. I'm just going to put another couple of 3s like that. Now, of course, we can then put the recurring decimal there. The idea is that it goes on forever. And that's a problem because we need to get rid of the recurring part of the decimal. Okay? It's okay for us to have a 3 in the decimal. It's not okay for us to have an infinite number of 3s. So how do we do that? Well, this is where the whole timesing by 10x or 100x or whatever comes into play. Because if I look at this, if I times this by 10x, let's say, I get 7.3, and then the 3 recurs forever as well. Yeah? So what I can do now is literally just do 10x minus x, and then I'll get my answer, right? Because the recurring parts will then all cancel out with each other. So the goal is, the reason why we do the x equals, the 10x equals, the 100x equals, the 1000x equals, is just to make it so the decimals, the recurring part, will cancel out. That's all we care about. We don't need to get rid of all of the 3s. That's the common thing that I see in a lot of students' work, and it makes sense because that's how it's taught. You're taught that you need to get rid of the 3. No, you need to get rid of the infinite number of 3s. So if you want, you could have 0.733 and then nothing. That's fine. You just need to get rid of the dot. So technically, if I do 10x minus x, that will get rid of the recurring decimal. If I do 100x, that would be 73.3 recurring. I can now do 100x minus 10x and get rid of the recurring decimal. I go 100x minus x and get rid of the decimal. So it doesn't actually matter. A lot of students will kind of have this ingrained in them where it's like, oh, well, it's 1 decimal place that's recurring, so I need to do 10x. It's 2 decimal places, I need to do whatever. It really doesn't make a difference. My personal belief about it is I would essentially do it as you have x equals this, and then just do, if there's 2 decimal places, do 100x. If there's 3 decimal places, do 1000x. If there's 4 decimal places, do 10,000x. And the reason for that is it will guarantee that the recurring parts of the decimal will line up. That is literally the only reason why I would do that, okay? So I hope that makes a bit more sense as to why you're doing what you're doing. But I'm actually going to write another 3 here and make that the recurring one, because if you notice, if I were to put these 2 numbers on top of each other, so 73.33 recurring and 0.73 recurring, when I subtract them, because there's like an infinite number of 3s, they will all cancel out to give 0. Okay? So after that, I'm just doing 73.3 minus 0.7, which is 72.6. Yes. So that equals 72.6. So 99x equals 72.6. So x equals 72.6 over 99. And again, I'm well aware that mark schemes will tell you to do certain things and put things in certain orders, but it's not necessary. And this is what I mean by you really need to understand what you're doing if you want to get that grade 9 at maths. And then as you can see, it simplifies to 11 over 15, which is the intended solution. Hopefully that makes a bit more sense. Here we have a histogram. It gives information about the distances AT competitors jumped in a long jump competition, and everything's here. Cool. Well, at least it looks like everything's here. How will I check? I'll have to find the number in each bar, add it up and see if it adds up to 80 to know. This is calculating an estimate for the mean. Okay, so this is a bit tedious, but that is fine. There's a couple ways to do this, and one way is to draw out the entire table of values. But I'm not going to do that just now. I'm going to try and explain it the way I would do it, which is we'll need to work out how many people are in each class, right? Each of these. How to do that? All you need to do is find the area underneath them. Pretty standard, not too bad. For example, this goes up to a frequency density of 10, and 7.2 minus 6.4 is 0.8. 0.8 times 10, that means there's 8 people in there. And then, if you remember how you work out the mean from grouped data, because remember, histograms are grouped data, you take the number inside the class and you times it by the midpoint. Well, the midpoint I can clearly see is 6.8. And then what you do is you add that all up for every single class and divide it by the total number that you have, which in this case is 80 because it's told me that we have 80 competitors. And that's it. So some people like to draw it out as a table. So they would write, 6.4 less than, it says M there for meters, 7.2, and then they'd write the value there and then do it from a table. Again, understanding is really key. This histogram is a representation of a table. So you don't need to draw the table up because this kind of is the table in a manner of speaking. So you don't have to do all that. So does it matter? Of course not. If you want to draw the table, go ahead. But again, aiming for grade 9, we need to improve our understanding, and this will actually save us time in the exam, and it will reduce the amount of errors we'll make. Okay? In your exam, you should be as lazy as humanly possible, because the lazier you are in your exam, the less likely you are to make mistakes. Okay? Doing a complex method means there's more opportunities. For example, when I'm writing out the table, what if I get one of these values wrong? My mean's wrong straight away. And I might not get any marks for the table. So I've actually lost marks for no reason. Things like that. Doing it from here, it's very hard for me to get the number wrong because I can visually see it. Okay, for the next one, the class width here is 0.4 because 7.2 to 7.6, and it goes up to 50. So 0.4 times 50, that's 2/5 times 50, which is 20. I don't know why that took me so long. So yeah, so there's 20 people in there. Had a bit of a brain fart there. 20, and then times the midpoint would be 7.4. 2 more bars, and this for 4 marks is pretty good in my opinion. It's just they put you in a different situation. The width here is 0.4 times 100. Well, okay, I don't need that one. That's going to be 40 people. So 40 times 7.8, that's the midpoint there. And lastly, but certainly not least, we have 8 to 8.2. I'll just add that as an 8.2 there. That's 0.2 times 60, so that's 1/5 of 60, which is 12. So that does all add up to 80, so that's good. So that's going to be 12 times 8.1. And now all you do is shove it all in your calculator and you're done. 4 marks. Pretty good, but if you try to draw out the table, again, I expect there to be... you're not saving as much time as you could be, which is, of course, a massive benefit in an exam where time is of the essence, especially for those last few questions. The ones that are unseen, the ones that are kind of crazy. As soon as I'm allowed to, I'm going to upload the last question from the 2023 paper. That was crazy. So you'll see what I mean. There's always going to be a crazy question. At least one. 7.645. I would say do it to 2SF because everything here is to 2SF or 1 dp, whatever you want to call it. So 7.6 to 1 dp. And that would be meters. Is that a long jump by any chance? That's pretty far. Okay, cool. But yeah, hopefully that makes sense. Again, we did that quite quickly. It's a 4-mark question. Not bad. So, algebra. If any of you want to do A-level maths, and if you're aiming for grade 9s, a lot of you are going to be doing A-level maths, algebra is so important. I currently have some year 12 students, and they're very bright, The thing that slows them down with the new content is the algebra. Guaranteed. So getting good at this is so vitally important. How do you get good at this? You're in luck. There are an infinite number of algebra questions out there, millions of them. You can just look up, algebra problems. You can even look up algebra problems from American universities or even universities in the UK, because algebra doesn't change. It's really, really an easy thing to revise. It's not easy, but it's an easy thing to revise. And this right here is a 3-mark question. Simplifying this, there's always mistakes. So what do? The first thing you do is you always try and factorize any of the brackets. So here, this looks suspicious to me. And again, this comes with familiarity, with practice. This first thing is a square number. 9 is square. X squared is squared, obviously. And 144 is also a square number, which means this is the difference of 2 squares. So just so you're aware, if you ever have something like x squared minus, let's say 16, for example, you factorize that to x plus 4, x minus 4. How do you get that? You simply square root the first thing, x and x, and you square root the second thing. Now when you square root 16, you get a plus and a minus. So you put the plus here and the minus there, job done. Do the same thing here. So we have 6x cubed over, if I square the first thing, square 9 is 3x. So I'm going to put that in the other bracket as well, 3x. Now if I square root 144, I get plus and minus 12. So I'm going to put a plus 12 in this one, minus 12 in this one. Okay? That's still divided by 2x to the power of 4 over 3x to the minus 4. If I have a look at this, I can actually factorize out a 3 from both of these brackets. So this is where the factorizing might get a bit tricky. So I'm going to do it in 2 steps, but normally I would do it in 1. So 6x cubed. I'm factorizing out a 3 from the first bracket, so 3x plus 4. Factorize the 3 from the second one, I get 3 again, x minus 4. I'm actually going to do the keep flip change, so we're going to change it to a times, and then we're going to put 3x minus 4 like that, over 2x to the power of 4. Now, these 2 3's, all of this is timesing each other. So I can do 3 times 3 if I wanted to, right? That would be fine. But I've actually noticed something even better. So it's actually good that I did it in 2 steps. But just so you're aware, that bottom bit right there would technically become this, because all of it is multiplying by each other. Now, what did I notice? Well, when you have a cross multiplication like this, you have a fraction and another fraction timesing, you can cancel out terms that are diagonally opposite to each other. So I could cancel out this with this. Now, what do I notice? Well, 3x minus 4 and 3x minus 4 are both here. Because they're exactly the same. Cool. If I made that 9, I'd have to divide that down to make 3 again. So that's why this is actually a preferable way of doing it. Now, what about cross-cancelling here? Well, the 6 and the 2, what's the biggest thing I can divide from both of them? I can divide them both by 2. So I'm going to change that 6 divided by 2, make it 3. That 2 goes away. What about x cubed and x4? The biggest thing I can divide them by is x cubed. So that goes away completely, and that just becomes x to the power of 1. So now let's write out what we have. We have 3 over 3x plus 4 times 1 over x. That's it. The 3 and the 3, I can cancel that out as well. So now I'm left with, and again, I'm doing this in more steps than I normally would, just to make it super clear for you guys. Times 1 over x. Well, if I times those together, you times the numerators times the denominators, that just becomes 1 over. Now, I'm going to leave it like this. Why? Because if I look at the answer, it says x plus r. X plus r. R is 4 in this case. And that's it. So again, take it nice and slow and work your way through nice and carefully, but practice algebra. It is the thing that's going to hold you back in GCSEs, but especially in A-level as well. Here we have a speed time graph showing the speed in meters per second of an object after it moved from rest, and it has this kind of a nice cool looking arc. It says use 3 trapeziums of equal width to work out an estimate of the area under the graph between t equals 1 and t equals 4. Cool. Using the trapeziums. All good. Now it says 3 equal lengths, so we're going to have 1 here, 1 and 1. So in other words, if I draw our lines, yes, and there. As you can see, if I were to draw these little lines here like that, that is 3 trapeziums right here. Yeah? So, what does that mean? Well, it says work out an estimate for the area under the graph. Cool. So, as you can tell, we're working out the area of each of these trapeziums. How fun. How do you work out the area of a trapezium? It is simply a half A plus B multiplied by H. H is just going to be the width of each of these things, which is 1 in this case, nice and easy. A and B are going to be these like diagonal heights here. So if I just label them like 1, 2, and 3 quickly. Okay, let's just do it normally. So we have a half for the first one. A, well, it goes up to 4. Plus, well, this one goes up to 6. And it's technically times by 1, but obviously we're not going to actually do that. Plus, half again. And this one goes up to 6, and the other one goes up to something else. So that's 6.5. That should be 6.6 then. Whoa, okay, that looks like a times, but it's of course meant to be an add. And again, times by 1 plus a half. And this one goes up to, well, 6.6, of course. And that one goes up to... no, okay, I made a mistake. So these go up in 2s then, so that should be 7.2. Okay. There we are. That means that should be 7.8, that last one over there. And of course times by 1. So, don't know why I put double brackets. There is an easy way to do this. I could factorize out the half. So if I enter this on the calculator, I could put 0.5, then open bracket, and basically just add all those numbers up, right? Because the end bit is 1, which is quite funny. So you can do that. If that's a bit confusing though, I'll do it the longer way. But you can just do 0.5 on the outside and then just add all those numbers up and it'll give you the right answer as well. 7.2 plus 0.5, 7.2 plus 7.8 gives me 19.1 meters. Oh, I just gave it away. What does that represent? It represents the distance traveled. In that kind of time interval right there. That's what it represents. Continuing with our theme of algebra, we have a fairly interesting indices question, which has ax to the power of 6 to the power of 1 over n equals 7x cubed. Now, in this type of question, a lot of students will freeze and they'll just say, I don't know what to do. But the thing is, you know the rules of indices, so just apply them. What happens when you have a power outside of a bracket? All you do is you multiply the indices. So that means a is going to be a to the power of 1 over n. Let me just make that pen a little bit smaller. And the reason for that is, don't forget, a here is the power of 1. Then there'll be x to the power of 6 over n equals 7x cubed. Now, the good thing about algebra is that this x term has to be the same as this x term. So in other words, x to the power of 6 over n has to be the same as x to the power of 3. Well, okay, that means 6 over n equals 3. Now 6 divided by what will give me 3? Well, that will be 2. And the reason for that is because these two things are equal here, the powers, the indices must be the same. Okay. Now you could rearrange this for n, by the way, or you can use the logical way here. Now, that also means the stuff in front has to be the same. So a to the power of 1 over 2 in this case equals 7. Well, what does it mean when we have a power of a half? It means we have the square root of a equals 7. Square both sides and we get a is equal to 49, and that is our final answer. Question 10 is actually very similar to one of the previous questions. So here's a speed time graph for a car, and it says work out an estimate for the distance the car travelled in the first 30 seconds. So this right here is testing your knowledge that the area under a speed time graph gives you distance, but you need to be able to do this carefully. It's an estimate for a reason. So if we look at 30 seconds, that is all the way up to here. We need to work out the area under that. Well, what is that shape? Well, it's a curve, so we actually don't know. It's going to be some kind of sector segment type thing. So what we're going to have to do instead is make an approximation. What I'm going to do is make this a giant triangle. I draw a straight line going down here, like that. We get that kind of shape here. And how do you work out the area of a triangle? It's half base times height, so that is going to be half times 30 multiplied by, what's that height? Well, it goes up by 2 in 1, 2, 3, 4, 5 spaces, so each one should be 0.2. So 8.2, 8.4, 8.6, 8.8. Oh no, 0.4 instead. 8.4, 8.8, 9.2, 9.6. Yeah, so here would be 8.4, 8.8. And then all we have to do is use our calculators to work that out. Just go to my calculator. 0.5 multiplied by 30 multiplied by 8.8 gives me 132 meters. And of course, there is a part B which says, is it an over or underestimate for the actual distance? Give a reason for your answer. Well, if I have a look at the shape I've drawn, this line is actually underneath the curve, which means the actual distance is going to be slightly bigger than that, because look, this area here, this thin strip here, has not been calculated, so it is an underestimate. As my line is under the curve, which reduces the area that we're talking about. Then for part C, it says Julian uses the graph to answer this question. Work out an estimate for the acceleration of the time at 60 seconds. Here is Julian's working. He does speed divided by time, so the speed is 13 and 60. Julian's method does not give a good estimate. Explain why. Well, if we have a look, the time he's picked is at 60 seconds here, and he's just said that 60 seconds, the speed is 13, so we did 13 divided by that. The reason is acceleration is the rate of change, right? It's the change in velocity over time. Change in speed over time. Whereas what he's done is he's just taken the speed itself. The other thing you could do is say that a gradient would be better because the graph is not a straight line. Either one of those would work out well. This question is a normal proportionality question, however with a bit of a twist, where they have two kind of different things. And this is quite interesting because there's a few ways to do it, and the way that I see in a lot of mark schemes is not the way I would do it personally, because it's a bit confusing. So the first thing we do is the same thing as usual, which is write out our equation. So x is directly proportional to the square of y. So x is proportional to y squared. We also have that y is directly proportional to z cubed. Now, because of this, I can actually sub this into here. That means x must be proportional to z cubed squared. In other words, x must be proportional to z to the power of 6. Now, the way that a lot of other places or a lot of mark schemes will do it is they'll write x equals ky squared and then y equals cz cubed, and then they'll sub them in, and then you'll have two different kind of constants, but they'll treat that as one big constant, which is the same as what I'm about to do. I'm just going to write x is equal to kz to the power of 6, but I just want you to be aware that sometimes they'll sub it in like this and then treat k and c as one big constant together, which I don't personally like because I think it doesn't make much sense to do it that way. Mathematically, this makes a lot more sense. Now we do exactly what the normal question is, which is we sub in our two equations to find, our two values to find what the constant is. So z equals 2 when x is 32. So 32 equals k times 2 to the power of 6. And 2 to the power of 6, of course, is 2, 4, 8, 16, 32, 64. So 32 equals 64k, and then k is just equal to a half. And therefore, we want to actually write our expression out because it says they want an equation for x in terms of z. That would be x is equal to a half z to the power of 6, which is our actual final answer for 4 marks. So the only additional step, and again, this is where I'm going to teach you how to get that grade 9, the only additional step is they've given you two equations and you just need to sub them in. The rest of the steps are exactly as normal. So from here onwards, that is the usual type of question that you're expecting. It's the only different bit is the fact that we've subbed in something at the beginning. But hopefully you can see that doesn't really change all that much. And here is a very unique ratio question, to be honest. Part A is pretty standard, but part B, it's pretty spicy. It's pretty unique. I like it. So for part A, we have 5c plus d is equal to c plus 4d. Find the ratio of c to d. A lot of students would again be a bit confused, but remember, all they're asking you for the ratio of c to d is how many times bigger is c than d, or vice versa. That's all it tells you. So what we're going to do is we're going to take this linear equation and we're going to put all of the c's on one side and all of the d's on the other side. So let's minus c from both sides. We get 4c plus d equals 4d. And then I'm going to move the d's to the opposite side. So 4c equals 3d. Now if I'm looking at the ratio of c to d, which I'm going to write over here, well, if I look, c is 3 times bigger than d. Now there is actually another way to do this, which I will show you as well. But if you like, c is 3 times bigger than d, so then the 3 would be on the left side, and d is 4 times c, so it would be on the right side. But let me show you another way. Let's say I want to work out what c is, so I'll make that c is equal to 3 over 4d. So that means c is 3 over 4 times bigger than d, which means c to d is 1. Sorry, one sec. It's 3 over 4 times bigger than d. Now we can't have fractions in ratios, so we times both sides of the ratio by 4 and we get 3 to 4. Either one of those methods works, but essentially all you're trying to do is work out how many times bigger one letter is than the other. In this case, c is 3/4 of d, so I've put that into the ratio, and then I've times it both by 4, both sides by 4, because we don't have fractions inside ratios. And that's how I've done it. In the same way that you can just look at it from this line if you'd like, but either way works. This way is more mathematically sound, it's not as much of a shortcut. So let's move on to this handsome looking equation right here. We have 6x squared equals 7xy plus 20y squared, where x and y are both bigger than 0. Find the ratio of x to y. Now this seems a bit crazy because we can't really get x's on one side and y's on the other because there's an xy term, there's kind of a hybrid term in the middle. So what can we do? Well, and we also have squared terms as well, which is a bit tricky. Well, whenever we have squared terms, it might be a good idea to use quadratics. So if I move everything over to the left-hand side, I get 6x squared minus 7xy minus 20y squared equals 0. Now this looks like a quadratic equation, right? Because you have like an x squared term, then you have a linear x term, and then you have a constant term at the end. So if you remember, when you have a quadratic, it looks like this, generally speaking. Right? You have a quadratic term, a linear term, and a constant. Here we have a quadratic term, a linear term, and a constant. So this is indeed a quadratic. And all we need to do is solve this. And the best way to solve it is by, I mean, technically you can use the quadratic formula, but you have y's here, so that's a bit tricky. So instead what we're going to do is factorize it. So if I put 2 brackets out, factorize however you'd like, to be honest. But I would say you'd probably have 2x and you'd have 3x. And 5 and 4. yeah, minus 5y plus 4y equals 0. So if I expand this, we get 2x times 3x, 6x squared, minus 15xy plus 8xy, which gives us this, and then we would have minus 20y squared, which gives us that. Perfect. So now, if we're solving this, we have 2x minus 5y equals 0, and 3x plus 4y equals 0. So let's move the the 5y over, and then we have 3x. Okay, so this solution over here doesn't work, because remember, it said that x and y are both bigger than 0, but here we have a negative value. So these two are like opposite signs to each other. So keep in mind, so we can say y is negative or x is negative, doesn't matter. One of them is going to be negative, and because our condition is that they're both positive, it doesn't work. So we're actually looking at this one over here. We can do the same thing. If I say that x is equal to 5 over 2y, then that means the ratio of x to y is 5 over 2 to 1, times both sides by 2, because we're not allowed fractions, and we get 5 to 2 for our ratio of x to y. So that's a pretty unique situation. That is one of the unseen kind of questions. But hopefully you can see it's the same as part A, realistically. This kind of wording is, again, very typical of grade 9 questions. So we have a curve with this equation, a line with this equation, and it says, show algebraically that C and L have exactly one point in common. And honestly, if I change the wording of this question, I guarantee most of you watching it would instantly be able to do it. And what do I mean? Well, if I said that, for example, find the coordinates where lines or L and C intersect, all of you would know exactly what to do. But that's exactly what this question's saying. It's just saying, well, how many points does it have in common? Well, how would you work that out? You would try and find what coordinates are in common. So it's the same question realistically, it's just worded very slightly differently. And that's the problem. So if I asked, write the coordinates or work out the coordinates where C and L intersect, a lot of you would be able to do that. But the problem is that they're saying show algebraically they have exactly one point in common. So they've given you a hint which actually makes it harder to understand the question, which is kind of weird. But you answer it in the same way. You're going to try and calculate the coordinates where C and L intersect, and it will turn out there's only one coordinate. That's how you show it. So you show it by doing the exact same process. So how do you do that? Well, when they intersect, it means that these x's and y's are actually the same, which means we can just sub one equation into the other. Now this one's already rearranged for y, so I'm going to sub it straight in. We have x squared plus 3x minus 3 minus 5x plus 4 equals 0. And now all we need to do is solve the quadratic. So x squared here minus 2x, and then plus 1 equals 0. So if I factorize this, the two numbers are going to be minus 1 and minus 1 equals 0. So that means the only coordinate is at x equals 1. Only one value. We don't even need to work out the y value because that's not actually what the question's asking. It's just saying show it only has 1. As you can see, I'll only have 1 because if I sub in one x value, I'll get one y value. And that's actually it for the question. Pretty quick, pretty easy, but again, the wording can really throw people off. So really try and understand what they're trying to get you to do. Okay? How would you show it has one point in common? By calculating the points in common, right? And see if there's only one. So I've got a bit of a spoiler on screen with the ruler, but it says here, the graph gives the volume of water in litres in a container at time t seconds after the water started flowing out of the container. And it says, use the graph to work out an estimate for the rate at which the water is flowing out of the container at t equals 12. So let's find where that is. So it's 11, 12. That is this point right there. Now, how would we do that? Well, for a rate, that's going to be volume per unit time. So this is actually it's basically just asking us to work out the gradient of the equation of the graph. Now, the reason again why this is tricky is because they don't word it very easily. They don't say calculate the gradient of the graph. They say work out the rate at which the water is flowing out, and you have to kind of deduce. Well, let's be frank, right? There's only two things you can do with this, which one is work out the area, and the other is work out the gradient. Those are the only two things you can do. Now, it says when t equals 12, not up to t equals 12. Now, that tells me that it's a gradient, not an area. Because with an area, they have to tell you a starting point and a finishing point. They can't just say, work out the, area at t equals 20. Because that doesn't make sense. At t equals 20, there's one value. There is no area. So, the fact that they haven't specified two values hints to me that they wanted me to work out the gradient, not the area. So that's one thing. The second thing is by looking at the units. If I do the area, that's litres times seconds, that's nothing, it's nonsense, it's litre seconds, that doesn't make sense. However, if I do litres divided by seconds, that's litres per second, which is a rate. So that's another piece of evidence. So all we have to do now is draw a nice looking tangent. That is pretty reasonable, actually. I'm fairly happy with that. Not bad, not bad. Again, you do get quite a bit of leeway. So now what we're doing is doing the change in y. So it goes from, what is that, 25, 6, 7? Yeah, so 26, 7. So it goes from 27 to 0. So it's going to be minus 27. And that's in 31 seconds. And I put a negative just because it is technically flowing out of the pipe. So get my calculator up. We have 27 divided by 31 gives me 0.871. Technically minus 0.871 because it's flowing out. But again, they're kind of okay with the sign. It doesn't matter too much. And the range of values are anywhere between 0.7 and 1. So that is in the range. All done. 3 damn marks for that. For one step, well, 2-step question. Really, really good. For this question we have some bounds, but we have a fairly interesting situation. So we have a cube, and of course the important thing with the cube is that all sides are the same. So all of these lengths here are all some length. We should call it, I don't know why I called it A actually, let's call it X. X and X. And it says AH, which is this diagonal length here, is equal to 11.3 centimeters, correct to the nearest millimeter. So what I would actually do is write that in terms of millimeters first. That just helps me make sure I don't make a mistake with the bounds. And it says calculate the lower bound for the length of an edge of the cube. So how could we work out the length of the edge when we have this diagonal length? Well, we can use 3D trig, which just says the same thing as normal trig, however you have 3 sides added together. So this diagonal side is going to be equal to this side squared plus this side squared plus this side squared. So all 3 of these sides squared. So it would be x squared plus x squared plus x squared should equal this length over here. Okay? So hopefully that makes sense. Again, you can look up the equation for 3D trig, but essentially a to h is going to be all 3 sides that make it up squared and added together. Now if we want the lower bound, we're going to be rearranging this, of course, because we have 3x squared equals some number. So we're going to be dividing and then square rooting it. So if we want the lower bound, that means we want to take the lower bound of the length AH. And again, if you want to do the upper and lower bounds, all you need to do is add or minus 0.5. So that would be 113.5 for the upper bound and 112.5 for the lower bound. So that equals 112.5. Divide both sides by 3 and square root. So that gives me 112.5 divided by 3, all square rooted. And pull over our calculators. 112.5 over 3 gives me an answer of 6.12 millimeters to 3SF. Now, of course, this is quite tricky because 4 marks, it's bounds, and bounds tends to be answered pretty poorly by students, but it's also a cube, they give you a weird situation, but also it uses 3D trig, which is, 3D Pythagoras, I should say, which is fairly tricky for a lot of students, okay? Because they don't really remember that you actually do cover that. Some students would try working out, for example, different lengths by using a diagonal here and then trying to use that, but don't forget, the diagonal here and the height and the hypotenuse are all going to be different lengths. You can't actually do it that way. It's not possible. So just keep that in mind. Here we have a vectors question. It looks like the top vector was actually smushed off. It's of course going to be a b because this is a trapezium, which means the opposite sides are parallel, so that is what it is. And vector questions tend to be very poorly answered, which is why they like to put at least one of them in each kind of year. If you're unlucky, it'll be something like this. However, I'm going to show you the method on how to actually get through this, because once you can, these 4 or 5 marks that you can get are really, really solid. I have got loads of vector questions on my channel if you would like to have a look. I even go through every single possible vector style question. But if we read this, it gives us a bunch of information here. D is on the point where it has ratios, cool. Work out the vector DE in terms of A and B. So DE is going from this point here, this point over here, to this point over here. So what I like to do is write out the steps on how to do that. So if I want to go from D to point E, what points do I have to go to? And you can go anywhere you want. You can go D to O and then O to C and then C to E. You can go D to B and then back round if you wanted to. You'd get the same answer. But I'm going to take the most direct route. So I would go from D to B, so D to B, and then I'd go from B to E. That's kind of the most direct route, right? It's 2 steps. Boom, 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 done. Okay, do I know either of those vectors? Well, I don't know D to B and I don't know B to E. So I need to write these vectors in terms of other vectors. So if I look at D to B, we have a ratio here which kind of illustrates it, it demonstrates it. And it says O to D, so this part of the vector here is 2 parts and DB is 3 parts. So in total, the D to B part of this line, so if I put this out here, 2 and 3, is 3 out of 5 parts, right? It's 3 out of a total of 5 of the line O to B. So again, let me explain that again. That ratio says that O to D is 2 parts, D to B is 3 parts, and the whole line is 5 parts OB. Right? If it's 2 to go from O to D and it's 3 to go from D to B, then it's 5 to go from O to B. So DB is just 3 out of the 5 total parts. We can do the same thing for B to E. So BE to EC, well, BE is 1 part, EC is 4 parts. So B to E is 1 out of a total of 5 parts, so 1/5 of B to C. Okay. Now we don't know those vectors, but can we work them out? And the answer is absolutely we can. So if I want to work out OB, again we can follow the same kind of steps, the same procedure. How do I go from O to B using vectors that I know? Obviously I can't go straight from here to here because I don't know any vectors here, but I can go up to A and then across to B. So what is that vector? Well, that's going to be A plus B, right? Because I'm going in the same direction as these vectors here. Now, of course, you can also go this way and then backwards, but we don't know the vectors C to B, so we can't do that. But if we worked it out, we absolutely could. And then the vector BC, we can do the same thing. However, I can't go straight down from B to C because I don't know what this vector is. I can only go along vectors I know. So I need to go from B to A to O, and then O to C. Now, if I go from B to A, I'm going in the opposite direction to this arrow, right? So the arrow is pointing this way, I'm going this way, which means I make it a negative letter. So that's negative B. Then we're going against A, so it's negative A. And then we're going along this letter, so that's plus 3B. So in total that becomes minus A and then plus 2B. Hopefully that makes sense. And again, the maths I'm doing here is not super complicated. The most complicated thing here is ratios, but breaking up a line into a ratio shouldn't be too tricky for you. So now I can actually sub these in. So we have 3/5 of O to B, where OB is A plus B, plus 1/5 of minus A plus 2B. Then all we're doing is expanding and simplifying, and we have our 4-mark answer. So D to E equals 3/5 of A plus 3/5 of B minus a fifth of A plus 2/5 of B. Then all we're doing is adding fractions, and since this is a calculator paper, that should make it even easier for you. 3/5 of A, so 3/5 minus 1/5 makes 2/5. 3/5 plus 2/5 makes 1 whole, so just plus B. And that is your final answer. And again, I would recommend, by the way, the last step, even use a calculator to work out the fractions, because students make mistakes when they're under pressure. But that's it for 4 marks. So vectors can be quite easy as long as you really simplify it, really break it down, okay? It's like playing a game. You're just trying to get from point A to point B or whatever in however many steps that you can do it in. So this is an iteration question, and normally iteration is very, very simple, very, very easy. However, they've actually switched it up. And again, you can expect them to always switch something up every single year in your exam, in each paper as well. So again, that's those 10% unseen marks. So here we have the start of year n, the number of animals is Pn. The start of the following year, Pn plus 1, follows this kind of relationship. So at the start of 2017, the number of animals in the population was 4,000. So I'm going to say that my Pn is 4,000. And then Pn plus 1 is 3,610. So let's write an equation for Pn plus 1 quickly. So that 3,610 is going to equal K times Pn, which is, actually, sorry, one second. That's Pn plus 1 is blank, and then Pn plus 2 is 3,610, because I've just realised that it's 2017 and then 2019, so there's a 2-year gap. So Pn plus 1 is K times 4,000, which means Pn plus 2, which is 3,610, is equal to K times 4,000. So that's 3,610 equals 4,000 K squared. So 3,610 over 4,000, divide both sides by 4,000, equals K squared, which means K is just equal to the square root of 3,610 over 4,000. So I have done a similar style question before, but just keep that in mind. All you need to do is follow the iterative process. So sub it in once, and then sub it in again, however many times. They could technically ask you to do it 3 times, so they could have said at 2020, the number of animals in the population was 3,200 or whatever, and then you just follow it 3 times, and you'll just get a K cubed instead. There's not much difference. Now, when we square root this, some of you might ask, how do I know if I take the positive or the negative value? Which is a very, very smart question. The answer is, let's see if it's actually, yeah, so 0.95. Well, if I think about what this is, it's the number of animals in a population, right? Well, if K is negative, it means that the population alternates between negative and positive. Negative and positive. Does it make sense that we have a negative population? No. So we're going to be taking the positive value for 3 marks. But you should be asking that question. It's very smart. This style of question I've seen quite a few different times. However, it's not normally as tricky as this. Now, why do I say it's tricky? Because they've added a little extra dimension to it. So we have these 4 identical rectangles, and we need to work out the coordinates of point C, so this point here, which, as you can see, is 1 length away and 1 width away from point A. So I'm going to call, like, any right movement, so the longer side, the length, because that makes sense to me. I'm going to call the thickness of it the width, because that makes sense to me as well. And we need to work out what the value of the length and the width are in order to work out what the coordinates of C are. So how do we do that? Well, we use the only other piece of information, which is this other coordinate here. Now, X and Y we can treat completely independently of each other, which is really handy. So if I look at the X coordinates for a second, right, it goes from 3 to 11, right? So 11 minus 3 is 8. And it does that in how many jumps? Well, it jumps 1 length to the right, 1 length, and then it jumps another length minus a width, because it's minusing this width here. If I put that in red, right? So this bit is actually gone. So if you look, it's on this corner. So it goes one whole length. It goes a whole length minus a width back. So plus a length minus a width. Hopefully that makes sense. So we've not gone the whole length of the rectangle, we've gone one width before. Okay, let's do the same thing with the y coordinates. Actually, before we do that, let's quickly just simplify this, because there you go, that looks a bit nicer. The y coordinate goes from 4 to 20, so it goes up by 16. And that happens in one width plus a length plus another length equals 2L plus W. So if you notice, I have these two equations. I'm going to write them on top of each other just to make it super clear. This actually makes a simultaneous equation, but it's a simultaneous equation that should be hopefully quite easy to solve because we already have one variable the same. So if I just add these two variables together, we get 8 plus 16, which is 24, equals 4L, which means L is just equal to 24 divided by 4, which is 6. Then we can sub this into, let's say, equation number 1, and we get 8 equals 2 times L, so 2 times 6, which is 12, minus W, which means W must equal 4. Like that. 5-mark question, by the way, pretty good. So the coordinates of C, it goes one length to the right, so that means the x coordinate is going to be 1L to the right, so that's 3 plus 6, which is 9. And it's one width above, so that's 4 plus a width, so 4 plus 4, which is 8. So it should be 9, 8 for 5 marks. Hopefully that makes a bit of sense. Now this 1 marker that comes up every now and then is always answered pretty poorly, and I'm going to give you a rule, but then I'm going to explain it. Essentially, they give you the same base number with different powers. Now if they ask for the highest common factor, you pick the number with the lowest power. If they ask for the lowest common multiple, you pick the number with the biggest power. So in this case, 98 to the power of 91. Now, why is that? Well, with the highest common factor, if I look at this number with the lowest indice, it makes sense that this number here is a factor of all of the others because it's just 98 times itself 53 times. So 98 times itself 64 times obviously appears in the 98 times table, right? I mean, these are just basically the 98 times tables. Same with the lowest common multiple. The smallest number that all of these numbers are a part of is going to be the biggest number here. Because if this was 98 to the power of 92, then of course it would be its next highest multiple. So it's essentially highest common factor, you pick the smallest value, lowest common multiple, you pick the biggest value, and that's it. But hopefully that makes a bit more sense as to why, but really have a think about why if you're a bit unsure. So this question here is one of those unseen questions, but this was probably the worst one that's ever been answered. And the reason for this is it relies on a very special property of regular shapes. And that property is that regular shapes are actually just made up of triangles. So that sounds a bit weird, but essentially with a six-sided shape like we have here, a hexagon, we can split this into 6 identical triangles. If it is a 7-sided shape, it would be 7 identical triangles. If it was an 8-sided shape, it would be 8 identical triangles. If you've ever done, and I recommend looking up the derivation of this formula here, that's where it comes from. Okay, the fact that these shapes are all just made up of equilateral triangles. So, if you have a look, I'm going to draw dotted lines here, just to show you what it looks like. As you can see, we have 6 triangles, and they are all the same length, even though it's a bit tricky to see that. Now, it tells me that each side is length x. And the interesting thing about these identical triangles is they're actually all equilateral triangles when it's a regular shape, which means all of the sides are the same and all of the angles are 60 degrees. So, if I wanted to work out the area of this, because the whole point of this is to work out that the area of the shaded region, right? So what we need to do that is work out the area of the big shape and take away the area of this small white shape. So the area of the white shape, I'm just going to call area of white, well, it's going to be 6 times, because there's 6 triangles, the area of one of these triangles. And if you remember, the area of any triangle is given by half AB sine C. So that's going to be a half times x times sine 60. So if I work that out now, we have something times x squared, but let's do on our calculators. 6 times a half is of course 3, and then 3 times sine 60. Technically you're supposed to know these values, but you know, why not? 3 root 3 over 2. So 3. This has given me marks already. So it then tells me about the bigger triangle, that it's enlarged by scale factor p to give the bigger hexagon. So that means each length is now px instead of x. To work out the area, we can do the same thing, because again, that enlarged hexagon is still made up of 6 identical triangles, but instead of the length being x like it was here, the length is going to be px. Everything else is the same. So the area of I'm just going to call it area of big is still going to be 6 times a half, but instead of x we're going to write px, and we're still going to have sine 60. So that means that's going to equal the same thing again, 3 root 3 over 2 px squared. Okay? So again, if they ever give you something like a regular hexagon in a question, you can always break it up into its component triangles, because working out the area of the triangle is easy, whereas working out the area of a hexagon is, there is an equation for it, but it's not one that you need to know. It's not one that you are taught. So from that information, we know we need to break it up into some other type of shape. Okay, so that's kind of another way of thinking about it. So it tells me, show that the area of the shaded region is just, if we look at it, we actually have the pieces. So the shaded region, I'm actually going to write this over here, is just the big hexagon minus the small hexagon. And then all they do is they factorize out 3 root 3 over 2 x squared. So if I do that, I'll factorize out 3 root 3 over 2 x squared, and we have p, that would be p squared, my bad, sorry. P squared minus 1. And then all they've done is they've moved the x squared to the end, because remember, they're all timesing each other anyway. So it doesn't actually make a difference which order we write these brackets in. And that's it for 4 marks. So not too bad once you know what you need to do. Like, the actual algebra isn't that bad, but knowing what to do, knowing to break it up into triangles is very tricky. It's not something a lot of people know, because this kind of proof, this derivation over here, is kind of skipped over. It's not done in that much detail. But just remember, you can break up regular shapes into triangles, just like you can do it with a square, right? If you break up a square, you get 2 identical triangles here, and so on. So keep that in the back of your mind. So here we come on to probability. However, this probability is quite tricky, because if you look, it says Pat throws a fair coin n times, find an expression in terms of n. So they haven't actually given us anything to do with how many times we throw it. They just say it's thrown a certain number of times. So we need to work out the probability that Pat gets at least 1 head and at least 1 tail. So the best thing we can do is work out the probability of getting either or, and then doing 1 minus it. Because in order to get 1 head and 1 tail, that is going to be 1 minus the probability of getting either of them, because those are the only possibilities, right? Either you get at least 1 of each, or you get either one or the other. So first of all, how do I work out the probability of picking up a heads? Well, in normal maths, the probability of getting 1 head would be a half. Getting 2 heads would be a half times a half, right? So it'd be a half squared. 3 heads would be a half cubed, and so on, right? Where the power is just how many heads that you want. So in this case, it'd be a half to the power of n. And likewise, doing the same thing for tails, a half to the power of n as well, because it's a coin, right? It's a fair coin, which means that the probabilities are exactly the same. Now, again, because it says at least 1 heads and 1 tail, the highest number you could get of either of them is n, right? So if I throw it 100 times, I could get 100 heads and no tails, or I could get 60 heads and 40 tails and so on. Now that we have that, the probability of getting both of them, so at least one of each, is going to be 1 minus these two things added together. So the probability of getting heads or tails, I realise I misspelled heads there, by the way, is equal to a half to the power of n plus a half to the power of n. Which means the probability of getting one of each, so the probability we're looking for, is 1 minus those two things added together. And that works as our final answer, but if you wanted to, you could expand the brackets to get this. But hopefully that makes sense. So just keep in mind that you are going to be using the 1 minus relationship a lot when it comes to probability. This question is also fairly interesting, it's fairly tricky. We get given a big triangle ABC, and then it's broken up into 2 smaller triangles which have the same angle, which is interesting. And we have to prove that AB over BD, so the ratio between the sides, is the same as the ratio between the other sides of the other part of the triangle. So because we've got this like letter X, it means we've got to use the angle at some point. Now, what could I use the angle for? Well, I could do sine rule or cosine rule, but I don't really see how that's going to help me, right? Because I don't have any sides. I'm just going to have letters, and it's quite complicated, right? Like, I mean, it's quite a bit. So what we need to do is get an equation that will relate ABBD and ACDC. And the one I'm actually thinking of is the area. So there are 2 ways to work out areas. One of them is the half AB sine C, and the other one is just half base times the perpendicular height. Now with the perpendicular height, that will be a value over here, which I'm going to call h. And the reason why I like that height is because it's the same for both triangles, because they come from the same point A. So that h is going to be the same for both of them, which means we can relate them. So I think that's what I'm going to do. So starting with the triangle ABD, let's get our 2 equations. The first one will be half AB sine C. So what is AB sine C? Well, it's going to be the 2 sides and the angle between them. So it's going to be half AB times, because I don't want to make it all the same, AD sine X. And the other thing will be half base times height, so half BD times h. And do the same thing for ADC. We have a half AD times AC sine X. And again, as you can see that a lot of this stuff's going to cancel out because the X's and the H's are going to be the same. And that's going to be half base, which is DC, times h. Now, does it look like I've got everything I need? Well, if we have a look, we have AD in both of these equations, which is one of the letters we need, and we have AC. We have the stuff we need. So what we're going to do now is these areas should be the same as each other, right? Like these two should be the same. So if I equate them quickly, we have a half AB times AD sine X equals a half BD times H. We can actually cross out the halves from both sides. We can do the same thing with the other one. X half DC times H. We can cross those 2 out. So now if I'm looking, I need some kind of fraction somehow, And the only way I'm really going to get that is by dividing, because look, the ADs will cancel if I divide, which means we'll have AB over AC, which we can rearrange, and the H's will cancel. So what I'm going to do, and the sin X's will cancel. So what I'm going to do is I'm going to divide these equations, so literally just put them on top of each other. So let's do that. We're going to have on the left hand side AB times AD sin X over the left hand side of this equation. AD, and those two cancel, times AC sin X. I should probably do my cancelling in red because it looks better. So cancel, 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 and then the sin X also cancel, equals the right hand side, which was BD times H over DC times H. So that also cancels. Anything else we can cancel? Do we want to cancel anything? So we have AB here, we have BD here, we have DC here, and we have AC. Okay, so we actually have everything we need, which is good. So AB over AC equals BD over DC. Now all we're trying to do is rearrange this. So the AC needs to come up and the DC needs to come up and the other ones need to come down. So I'll do it in a couple of steps. So times both sides by AC DC, we get AB DC equals BD AC, and then divide both sides by DC BD, and then we're done. Yeah. Equals AC over DC. Okay, that was quite an interesting one. That's probably one of the trickiest questions I've seen, because knowing to do the area and then knowing to equate them and then knowing to divide them is not the easiest thing in the world. But I'm going to put the links to the other aiming for grade 9 papers and the YouTube videos associated with them. Make sure you have a go after a couple of days. Make sure you can kind of piece together roughly why I did what I did, and I will see you in the next one.